Now we talk about the mathematical tool 3, and we continue with the concepts of our uh, vector product. So far we have dealt with vector addition, and we found actually we have only two formulas: triangular law and parallelogram. We started with parallelogram law and we concluded with triangular law, that half of parallelogram law is triangular law and that can be implemented. Now, one thing should be very clear, that the relation of coordinate geometry with our vectors, because when you talk about a vector you are actually talking about coordinate geometry because everything is in space. So try to understand my words very clearly, that once we talk about coordinate geometry and we talk about three axes, we talk about three axes. We have x or y. Suppose say this is my y, this is my x, and this is my z. A three-dimensional concept. So once we talk about coordinate geometry, we talk about this is my y, and this is my x, and this is my z. This is a point, suppose say, and this is my origin. When we talk about this in vector, we are very clear. We talk about a point P. Suppose say P is a vector and we indicate like this. Suppose the point P is here, and coordinate of P, coordinate of origin is 0, 0 and 0. Means x, y, z, all three values are 0 at origin. If P is on xy plane, please try to understand this. It's quite tough job to explain the matter on videos. Even in real classes it poses a serious problem to make you understand. Lots of examples from the classroom itself is being praised, and we have to be very clear about this. So please pass your comments so that you understand everything. Otherwise, I repeatedly told you that my time will be going in waste. You cannot get best of it. Suppose say I consider this is what is x, y and z. They are nothing but scales. We consider them to be scales. So 1, 2, 3, 4. Suppose say 4 is the mark. Here P is corresponding with 4. And here we also have the division 1, 2, 3, 4, 5. Suppose this is 5. So P is corresponding with 5 of y. And in the coordinate we'll record this as, for x-axis we'll write 4, for y-axis we'll write 5. That means this is nothing but a two-dimensional point. The vector is also two-dimensional. In vector I'll talk later, but now I'll consider about coordinate geometry first. We consider this to be two-dimensional. That means point P lies on the xy plane. If point P lies on the xy plane, then coordinate geometry, the vector will be having only two components. So let me go to that first. I'll start with 2 dimension, then I'll give example of 3 dimension. Suppose say you consider P to be a vector. Vector can be noted as arrow or 1/2 arrow or a bar. Normally we give a bar. So along the x-axis we consider some unit vector I, and along y-axis we consider j, and along z-axis we consider k. Please try to understand this. I, j, k, English alphabetically, they are also in sequence like x, y, z. So I is an unit vector along the direction of x. Now what is unit vector? That question will arise in your mind. So unit vector is a vector, some vector say x, divided by its magnitude. So any unitary method gives you the value of unity. That means we have a direction. Please note one thing, in the whole concepts of vectors, we can never divide vector by vector. Dividing vector by vector is a Himalayan blunder. We can never do this. So once you have this, you talk about some value. See, value of this is divided by its own value. So what is remaining is 1, but direction is remaining. So this can be also considered as I. Got my point? So similarly, you can say y by magnitude of y as j, and z bar by magnitude of z bar is considered to be k. That means the direction is same, but direction is as that of x, but magnitude is just 1. For example, if you are standing in a metro station in CP and somebody asks you which way I should go to Dwarka, the answer will be very simple. If you are very smart, you will say go towards RK Ashram road. Of course, you are telling just one stoppage ahead, but direction is correct. Direction is very correct. That you are saying you go towards RK Ashram road. That means 1 unit. You are not saying the exact destination of Dwarka, but of some point in some metro station in Dwarka, and you are just saying 1 station ahead. So magnitude is 1, but direction is that same. This is the meaning of unit vector in real life. Now, let's talk about, suppose I want to denote this. Along x-axis I have 4, along y-axis I have 5. I want to denote this in vector notation. So what I'll do, I'll just write 4i plus, I'll write in equation form 4i plus 5j. 4i plus 5j. This is my exact notation of the p vector. This is p vector now in this direction from origin. Because what actually I am writing, if I go by coordinate geometry, I am writing 4 bracket, I actually am writing in bracket 4, you take 4 here, bracket 0 minus I, because 0 has got, this is the beginning, origin minus this minus origin. So sorry, I wrote in the wrong way, I minus 0, because 0 is nothing, no vector. So you can write this. I'll discuss this later. It may make you confused for the time being. Let me go to 3 dimension now. Suppose say you have a concept here. Suppose say you have a concept here. You have a concept here. You want to make it 3 dimensional. So to make it 3 dimensional, we don't have any great show. We can easily do it, and Suppose say in this direction, in z direction also, this is nothing but a scale, 1 2 3 4. Suppose say 3 is a mark, and I mark it here 3. Now this p point actually comes up. I'll change color and show you how it works. 3 p point, p is coming somewhere here because it has to be correlated. 5 is already for y, 4 is for x, and somewhere here 3 for y. So it is in 2 dimensions, it's very tough to draw. I can draw it somewhat here. P is coming somewhat here like this. So no, it is somewhat like this here, suppose. So this is corresponding with 5, this is corresponding with 4, and this is corresponding with 3. So now it is 3 dimensional. So in the equation, what changes you will do, just write 3k, that's all. This is a new change. So if you have 2 vectors in the coordinate system, now we have 8 coordinate. Now I'll go to Indian methods of directions. In Western concept, they have in a plane, north, east, south, west. This is north, south, east and west. We have only these 3, east and 4 directions. There can be northeast, which is actually just 45 degree. There can be southeast, which is 45 from south, and there can be some numericals. They say 30 degree from east of north. East of north means this. Actually, they're talking about 60 degree from east. That is not northeast. So you should consider this very carefully. Now Indian method says this 8 directions are okay. 8 means northeast, southwest 4, and northeast, south, northwest, southwest, southeast makes 8 directions are fine. But above and all, we have on top we have other, and other means down, down and up. Adha and Udha, 10 directions. In physics or mathematics, we use this concept of direction. In my previous videos, I talked about that same coordinate with 4, 5 and 6, some numbers, some coordinate of Cartesian coordinate. We can also represent this with angles. In 2 dimension, I said r theta is the angle by which we can represent this P. And in 3 dimension, it should be not only r theta, it should be also r theta and some other angle, because without some other angle you can consider this to be 3 dimension, and you should consider this to be r theta and phi, some other angle. To explain this in a class, it's quite easy, but I'm trying to explain you as much as possible. For example, take an example which I mostly give. This is a runway of a plane. A plane starts moving in this direction. After some time, it tilts to take off. So this is one angle. This is one angle. Suppose this is our theta. So the airport authority will direct the pilot to take off with certain angle. This is theta, suppose. Now the flight has to go not in this direction but in this. Suppose this is my east, and the flight has to go towards north. Now airport authority will direct them to move towards, suppose 90 degree towards north. But 90 degree towards north to whom? Because the flight is still now tilted. With this angle is maintained, this theta is maintained. So there has to be some other angle which is perpendicular to this plane. So if this is my plane, suppose this is one plane, this is one plane, because I'm talking 3 dimension, here we have another plane. So theta is the angle with this plane. Theta is angle with this plane of the flight, which is my airport runway, and this is another plane. And if the flight takes 90 degree, they cannot say exactly north. They have to say some angle with this angle, this plane. So when the flight goes in this direction, a phi angle is made here. What I mentioned here. This is the whole concept of 3 dimensions. So you have a phi angle with which the maintaining theta, the flight is taking a phi angle. So this you have to understand very carefully. And this is the concept we are going to implement very seriously in our whole process of understanding vectors. Now, once we have a clear concept of this, we can talk about representation of vector in a just other way around. What I explain you now, I'll give an example the other way around. How it is other way around? I'll give you some vector and we'll analyze how it is represented in the coordinate system. So let me draw for namesake some coordinate system giving x and y. Please note this very seriously.